Lanhai is a national high-tech enterprise with over 20 years of experience, focusing on the pulp and paper making as well as wastewater treatment industries. Its core business centers on providing professional stock preparation system, solutions and complete sets of pulping equipment for pulp manufacturers. Lanhai KTM high-yield pulp preparation system has forged core competitiveness in the industry by virtue of its scientific and efficient technological process, ultra-low operating energy consumption advantages, and innovative energy recycling mechanism. Raw material chips are fed into the material preparation pit by a loader, then conveyed to the swing screen for classification via metering screw. The oversized large chips are crushed by a ray crusher and returned to the screening equipment. The undersized chip dust is transported out for disposal. Accepted chips, after being subjected to magnetic separation for iron removal, enter the chip washer for processing to remove surface dust and internal impurities. The washed chips are dewatered by the dewatering screw. The separated wastewater is first filtered by microfilter and then treated in high-efficiency sedimentation tank for precipitation, and the supernatant is reused for chip washing. The sediment at the bottom of the tank and various slag discharges are collected separately and transported to subsequent process for final disposal such as incineration or resource utilization. The dewatered chips enter the pre-steaming screw-through, the bin feeder for heating and softening. The initially softened chips undergo mechanical treatment in a single screw tearing machine. The chip structure is loosened through crushing and tearing to improve the permeability of the chemical solution. The chips after tearing pre-treatment are conveyed to the rotary drum digester. Under the action of high temperature and chemical agents, effective softening of lignin and fibers is achieved. The quality of the finished product is precisely controlled by adjusting parameters, such as temperature, reaction time, and chemical concentration. The softened chips are evenly conveyed to an extrusion shredder, where residual pectin, resin, and a small amount of lignin are further separated through the dual effects of mechanical extrusion and tearing. Softeners or bleaching agents can be flexibly added as needed for product customization. After being shredded, the materials enter the vertical reaction vessel, where fiber structure optimization reactions are carried out, using the residual heat from shredding and chemical additives. Optimized fibers are mechanically defibrated in a pressure refiner. After defibration, pulp is then blown into a cyclone separator, where steam heat is recovered and reused in pre-steaming. Discharged pulp is diluted in a dilution screw, then stored in a surge bin. After dilution, it is conveyed by a screw to a dual mesh rotary drum dewatering device for medium-high consistency, solid-liquid separation. The separated pulp are sent to the latency chest for fiber dilution. The pulp from the latency chest is pumped to two series-connected double-disc refiners. For low consistency refining after refining, the pulp is diluted again and pumped into a first stage to section pressure screen for screening. The tailings generated are returned to the dual mesh drum dewatering collection screw for pulp dilution. Accepted pulp from the first and second pressure screen is further dewatered in a dual mesh rotary drum high-pressure dewatering device. The finished pulp can achieve a dryness of up to 50%, which can be directly used as paper-making raw material or sold as market pulp.